Okay, pre-calc fans. Today we're looking at exponential equations using logs. So that's right, these are the types of equations where you cannot get a common base. So no common base. Okay, so our rules are still the same. We need to isolate the base. That's still the same. Okay, so what's my algebra telling me to do? I got to add, right? So that gets me a 19. Now I got to divide by 5. Okay, so I have what? 3 to the 2x power equals 19 divided by 5. That's actually a nice decimal. So 19 divided by 5 is 3.8. 3.8. Now, these bases are not the same. Okay? We cannot get common bases here. So, what we have to do is what's called take the log of both sides. Okay? Then once we take the log of both sides, we have a rule, exponents go in front. In front. Okay, they become coefficients. All right, and we solve. All right, so how does that look? We literally take the log of both sides. So I go log of 3 to the 2x equals log of 3.8. And now this 2x, this exponent, goes in front. And of course, I'm running out of room. So I'm going to write 2x log of 3 equals log of 3.8. Okay? Now, you have to see this as no more as a linear, as an exponential equation. This is linear. That log is just this fancy button on a calculator. Oh yeah, by the way, you need a calculator. If you don't have a calculator, you're not going to be able to do these problems. Okay? And don't use your phone. That's just going to make your work harder. Okay? Okay, don't use the phone calculator. Use a good calculator, okay? It can be a graphing or if you downloaded a special app. But if you take your iPhone and turn it sideways, those calculators aren't that, they're okay. They're not really good for doing this work that we have to do, okay? So, now my algebra just tells me all I got to do is just divide. These are coefficients. Log 3 is some ugly decimal in your calculator. So this is saying 2 times that ugly decimal. So all you have to do is divide both sides by this 2 log of 3. And now this, you very, 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 very carefully type it in your calculator. And most calculators, you need parentheses for the denominator. So if you do it correctly in your calculator, even on this one, so log, log of 3.8 divided by, open parentheses, 2 log of 3, close parentheses. Now, for those of you that have the graphing calculator, when you go to hit log, it's going to give you an open parentheses. So then when I type in 3, you got to close it. So you would do 2. So open parentheses 2 log, it automatically gives you an open parentheses. You got to close that 3 and then close the calculator one more time. Okay? So yeah, so in your graphing calculator, it would be a log, and it would be an open parentheses automatically is given to you. So then it's a 3.8, close your parentheses, then hit your divide sign, then do the rest. Now I hit equal. And now I have my 0.608. We'll round everything to the nearest thousandth. Done. Okay? I cannot multiply these two together. that 5 has an exponent attached to it. There's no exponent. These are not the same base. So what's the first thing I'm going to do? That's right, divide by 6. So then I have 5 to the 2x minus 3 equals whatever 15 divided by 6 is. So 15 divided by 6 I think is a nice decimal. Yep, 2.5. And I got to take the log of both sides. So it's log of 5 to the 2x minus 3 equals log of 2.5. That's right. Now, this is, there's my exponent right there, 2x minus 3. So when you write this out, you're going to put parentheses. So parentheses, 2x minus 3, close parentheses, then do your log 5 equals log of 2.5. Okay, I'm running out of room. I'm going to put this on another piece of paper. Okay, now, what do? I mean, I can distribute this log. It'll be a pain in the butt, but we can do it. I'm going to divide both sides by the log 5. Actually, do I have room right here? Yeah, I do. So I got 2x minus 3 log 5 equals log of 2.5. So I'm going to divide both sides by the log of 5. So then I'm going to have 2x minus 3 equals whatever this gobbledygook decimal point is. And then everything else you should be able to do in your calculator. You guys have the ability to do that. So log 5 divided by log of 2.5. Remember, for those with this graphing calculator, you got to be careful, cognizant of your parentheses. All right, so I have 1.75647 dot 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 dot. Now, algebraically, what do? That's right, we add 3. So right there it is. I don't need to show the work. You're in pre-calc, you should be able to do that. Add 3, so plus 3, hit equal. And now what? And then we divide by 2. Divide by 2. Hit equal. So our final answer, x is equal to 2.378, rounding to the nearest thousandth. Okay? You get down to here, she will do that. Oh, add 3, divide by 2. Boom. Type it right in your calculator. No excuses. All right, let's look at this one. 4 to the 5 over x power. So we're going to take the log of both sides. All right, I'm going to take a shortcut here. Where does the exponent have to go in? Right, it has to go in front. So I'm going to write 5 over x log of 4 equals log of 21. Okay? Now, I am not going to divide by log of 4 right now. How do I look at this? How do I write this out? What does this actually mean? That's right. This x is in the denominator. That log 4 is over 1. So you're actually looking at 5 log of 4 over x equals log of 21. Okay? Now what? That's right, you would cross multiply. We'd multiply by x. So it'd be x log of 21. Well then, don't I eventually have to divide by log of 21? So why don't we just flip-flop these two spots? I'll put this x over here, and I'll put the log 21 under here. Because remember, I don't need to show it, but this is over 1. So I can flip-flop those two spots. So I have 5 log of 4 over log of 21 equals x. Now I just got to type this all in the calculator and I'm done. So x will equal whatever we get out of here, round it out to the nearest thousandth. Okay? So 5 log of 4 divided by, now my calculator knows order of operations. It's going to do 5 times the log of 4, and then it's going to divide by log of 21. Again, for those of you with the graphing calculator, you got to be very, very careful. You got to understand what's going on. You got to make sure you use your parentheses. All right, divided by, where are we here? Log of 21. So 2.77. So 2.277. So there that. 2.277. That's 7 changes to 6. All right. Oh, we have to know remember our log definition from last year. Our log definition from last year. Oh my Lord. That's right. Log base b of n equals an exponent. That's right. A log is just an exponent. This is log form. I'm going to convert this to exponential form. This is the base. Here's the exponent equals the number. Okay? There's the base. Exponent equals the number. Okay? B for base, N for number, EXP for exponent. B for base, EXP for exponent, and then there's the number. So, what does that mean? Here's the base. Here's the exponent. Here's the number. So 5 to the power of x equals 17. That's right. Can I get a common base here? No. We got to take the log of both sides. So we have x log of 5 equals log of 17. Just got to divide by log of 17, log of 5. So x equals log of 17 over log of 5. And whatever that decimal is. And you're done. By the way, you just picked up another exponent law. That's right, it's called the change of base. Look at that. Look at what happened here. Look at this compared to what's over here. All right, this is base 5. Our calculators cannot do base 5. Actually, our calculators, the 84s can do base 5. They can do any base you want it, but why bother doing all that extra steps? Okay, just know some rules and it makes life easy. So it's the log of 17. Remember, no base showing it's 10, base 10. That's what your graphing calculators can do. That's what my scientific calculator can do. Okay, so it's log of 17 over the log of 5. That's actually a change of base formula. All right, last one that we're going to do. Actually, let me write that out, that change of base formula. So if I had x is equal to log base b of a, that is the same as the log of a with a base 10 over the log of b. This is your change of base formula. Okay. So log base b of a. So now, when you don't see a base here, we always assume it's 10. Okay, we're not going to do 6. We got number 5 to do. Number 5's a doozy. A lot of work involved. Last one. Okay. In fact, I'll do it on another sheet of paper so I have plenty of room. Okay. We can't get a common base, right? So we start by taking the log of both sides. Where do those exponents go? In front. Use parentheses. Okay. There. Now I distribute. I cannot divide. If I divide right now, I have some big gobbledygook decimal times this. I'm not going to do that. I want to leave everything in terms of logs. Okay, so watch what happens here. Remember, log of 6 is some gobbledygook decimal, some big ugly decimal. All I got to do is distribute. Okay, so it's just x log of 6 minus 2 log of 6. There you go. I just distributed log of 6. These are still the exponents because they're in front. And I'm going to do the same thing over here. 2x log of 4 minus 5 log of 4. All right, we did the hard stuff. Now, remember, this is a linear equation now. It's not exponential. This is linear. Some decimal point, x. 2 times that big ugly decimal. I don't want to write all those decimal points down. I'm going to leave it in terms of logs until I'm done. Okay? So, don't we have x's on both sides? So you have a big decision to make. What side do you want to put your x's on? It doesn't matter. Close your eyes, pick your favorite side. I think what I'm going to do is going to take all my x's, I'm going to move them to the right-hand side, just because 2x here and that's an x. So I'm going to take that x log 6, and I'm going to move it to the right. Well, if I'm going to move this one to the right, where do you think this negative 5 log 4 has to go? That's right, it's going to go to the left. And how do we move things left and right? That's all we can do is change their signs. So I'm going to take care of the x's first. So I have on the right-hand side, that's this side over here, I have a 2x log of 4. And this is a positive here. I kick it over the equal sign, becomes a minus. Okay. Now, taking care of this, moving the negative 5 log 4. Well, if it's a negative 5 on this side, a negative on this side, when you kick it over the equal sign, it becomes a positive. So I'm going to, because it's positive, I'm going to write it first. If it was negative, then it wouldn't matter because that's a negative. I always like to try and put the positives in front. So I have a 5 log 4 minus 2 log 6. All right. Now, I can't combine these because they're different logs. It's a log 4 and a log 6. We can't combine. But don't they both have an x in common? That's right, they do. So I can factor out an x. And now I have 2 log of 4, parentheses, 2 log of 4 minus log of 6, close parentheses. Okay, so I factored out the x. Now, isn't this just some big giant product, x times whatever this is? Yeah. Okay, if you wanted to convert this to a decimal point right now, you can, but carry lots of decimal points because I want my final answer rounded to the nearest thousandth. All you have to do now is divide both sides by whatever's inside here. Okay? This cancels. X equals whatever that decimal point is. You have to be very, 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 very careful typing that into your calculators. You need parentheses. And for those with the graphing calculators, be careful because remember, with the graphing calculator, they give you the open parentheses, so you got to remember to close. Okay? On my little scientific here, it doesn't happen that way. But I have to start with an open parentheses. So all I got to do is just type it in. 5 log 4 minus 2 log 6, close parentheses. I just took care of the top. Divided by, open parentheses, 2 log 4 minus log 6, close. Hit equal. So I have 3.413. Most of you who are using a graphing calculator, trying to do this in the calculator, you're probably going to screw up your parentheses, not having enough. Okay? So you got to be very, very careful, folks, with the graphing calculators because of how the graphing calculator does its logs. Remember what I said before on the other side, the graphing calculator, as soon as you hit the log button, gives you an open parentheses. So then when you type in your 4, you got to remember to close your parentheses. Okay? So you have to be very, very careful for those of you that have a graphing calculator. This is what it would look like in a graphing calculator. You would have an open parentheses, then you would have your 5, log, open parentheses, because that's what the calculator does, then you got to close it, minus 2, log, the calculator automatically gives you an open parentheses, type in your 6, then you got to close it, and then close one more time for the top. Now the top is taken care of. Okay, then you hit your divide button. Then you got to do an open parentheses. Then we start typing in the 2, log. And remember, the calculator automatically gives you an open. So 4, close it, minus log. Calculator automatically gives you the open, close, and then close it one more time for the entire bottom. Hit equal and get you 3.413. All right, folks. Have fun doing these problems.